Okay, we will restart the meeting. I want to introduce Martha Sandy and Meltem Musa. Martha Sandy is the Chief of the Reproductive and Cancer Hazard Assessment Branch in the Office of Environmental Health Hazard Assessment. And Meltem Musa is a staff toxicologist in the Safer Alternatives and Biomonitoring section within that branch at OEHA. Martha and Meltem will be presenting a recommendation to the panel on the potential expansion of the PFAS designated chemical group. Good morning, and thank you. It's great to be here in person with everyone. So I'm Martha Sandy, and I'll be starting off this presentation, then handing it over to my co-presenter, Meltem Musa, and I want to welcome her to Biomonitoring California, her first meeting with us. So we will be discussing the potential expansion of the existing designated chemical group, perfluoroalkyl and polyfluoroalkyl substances, or PFASs, to PFASs and other substances with carbon-fluorine bonds. We prepared a document on the potential expansion of this chemical group, and that document is available on the Biomonitoring California website as part of this morning's meeting materials. This document was originally provided to the Scientific Guidance Panel and posted on the Biomonitoring California website in August. This talk will highlight some of the content that is covered in more detail in that document. So now for some background on the existing designated chemical group. In March of 2015, the SGP recommended that PFASs be added to the designated chemicals list. And later that year, in November 2015, the SGP recommended that PFASs be added to the priority chemicals list. These listings include chemicals covered in the 2011 publication by Buck et al. For members of the audience, let me explain what designated and priority chemicals are. Designated chemicals are the entire pool of chemicals that can be considered for biomonitoring by the program. They are designated based on inclusion in CDC's National Reports on Human Exposure to Environmental Chemicals program and on recommendations by the Scientific Guidance Panel for Biomonitoring California. Priority chemicals are those recommended by the SGP as priorities for biomonitoring in California. Since the addition of PFASs to the designated and priority chemicals lists in 2015, there have been a number of presentations and discussions on PFASs at SGP meetings covering a variety of topics. On this slide, I have indicated meetings where PFASs were discussed. Several of these meetings, identified here in the red boxes, have featured invited presentations from researchers on various aspects of biomonitoring and environmental monitoring of PFASs and other organofluorine chemicals or total fluorine in these media. We've also heard presentations on identification of exposure sources and exposure pathways, and on pharmacokinetic modeling and more. At the November 2021 meeting, after presentations from program staff on analyses of PFAS data from a number of Biomonitoring California studies, and presentations from invited speakers on targeted and non-targeted methods and findings on PFASs and other organofluorines in biological and environmental samples, and discussions with the panel requested that the program report back on the PFASs chemical group. At the next SGP meeting in March of 2022, a number of options were discussed, including expanding the PFASs chemical group. The panel expressed interest in broadening this PFASs chemical group on the designated and priority lists, as did other meeting attendees. This slide was presented in March 2022 during our report back on this PFASs chemical group. As you can see, the figure presents various groups of PFASs, different groups of fluoropolymers and non-polymers, and all, I want to make the point, are aliphatic substances. This limitation, the exclusion of aromatic compounds, was pointed out during our report back in 2022. Well, since 2011, there has been a dramatic increase in scientific research on fluorinated chemicals. And this slide shows this with the number of articles published on PFASs and other fluorinated chemicals plotted year by year from 2011, where approximately 500 articles were published in that single year, to 2023, where approximately 2,000 articles were published in that year alone. As a result of the increased amount of scientific research that has been conducted on PFASs and other fluorinated chemicals since 2011, we now know a lot more about the uses and the sheer numbers of these chemicals in products, the environment, and biota than ever before. This is the result of increased development and application of expanded analyses using both targeted and non-targeted approaches to measure perfluorinated and polyfluorinated chemicals, and application of methods to measure total organofluorines. In the years since 2011, we also have an increased amount of information on the toxicity of PFASs and other fluorinated chemicals as a result of published epidemiology and animal toxicology studies, as well as findings from mechanistic studies and other NAMs. So today, the program recommends that the PFASs designated chemical group be replaced with an expanded chemical group, specifically perfluoroalkyl and polyfluoroalkyl substances and other substances with carbon-fluorine bonds. This slide shows some examples of chemicals containing carbon-fluorine bonds that would be included in the proposed expansion of the designated chemical group. You can see here parachlorobenzotrifluoride, or PCBTF. It's a solvent. It is used for metal cleaning and in products such as paints and inks. Perfluorotoluene is a solvent. Benzotrifluoride is a solvent. It is also a chemical intermediate used in the production of other chemicals. And the last chemical on this slide, perfluoropropylbenzene, is available for purchase from multiple chemical suppliers. Here are additional examples of chemicals that would be included in the proposed expansion of the designated chemical group. 1,1-difluoroethane is used as a refrigerant, a propellant, and a foam expansion agent. It is also a chemical intermediate in the production of pesticides and consumer products, such as cleaning products and air fresheners. Difluoromethylbenzene is a chemical intermediate used in the production of other chemicals. 1,4-nitrobenzene is a component in hair dyes. It is also a chemical intermediate used in the production of other chemicals. Fluorobenzene is a solvent and is used in industrial processes such as steel production. It is also a chemical intermediate. And now I'll turn the presentation over to Meltem.
Thank you, Martha. As a reminder, here are the criteria for the scientific guidance panel uses for recommending designated chemicals. The criteria are exposure or potential exposure, known or suspected health effects, the need to assess the efficacy of public health actions, availability of a biomonitoring analytical method, availability of adequate biospecimen samples, and incremental analytical cost. It is important to note that these criteria are not joined by the term "and." In the next couple of slides, I will be going over some examples of chemicals that would be included in the expanded chemical group and discussing relevant information on exposure and health effects. The document we prepared on the potential expansion of this chemical group provides additional information relevant to the criteria. This slide lists example chemicals with carbon-fluorine bonds that would be included in the proposed expansion of the designated chemical group, for which there is information on exposure or the potential for exposure. Examples of chemicals that have found in groundwater include PCBTF and benzotrifluoride. Examples of chemicals that can be present in the diet and for which the US EPA has established tolerances on several types of fruits and vegetables include bifenthrin, which is an insecticide used on numerous crops in greenhouses and building to control insects such as ants and termites, and cyhalothrin, which is another insecticide used in agriculture. Bifenthrin has also been detected in dust samples in urban settings, such as homes in Oakland here and homes of farm workers in Salinas. Examples of chemicals that have been detected in air include PCBTF, which has been detected in workplace air in vehicle and paint manufacturing plants. Difluoromethane, atmospheric concentrations of this chemical have been increasing since 2009. An example of chemical detected in wildlife is bromethylene, a rodenticide, which has been detected in birds in San Francisco in California. And an example of chemical detected in human biospecimens is fipronil, a pesticide used to control insects such as ticks and termites. Its metabolite fipronil sulfone has been detected in the serum of North Carolina residents with no known exposure to fipronil or other pesticides. It has also been detected in human cord blood samples in a study conducted in China. This slide lists example chemicals with carbon-fluorine bonds that would be included in the proposed expansion of the designated chemical group, for which there is information on health effects or the potential for health effects. Examples of chemicals that have been identified as carcinogens and are on the Proposition 65 list as causing cancer include PCBTF and tetrafluoroethylene. Tetrafluoroethylene is used as a chemical intermediate and to make polymers such as PTFE. Other chemicals that US EPA has identified as Group C possible human carcinogens include bifenthrin, fipronil, and ethylpyrrolane. An example of chemical with endocrine disruption activity is bifenthrin, which has been reported to lower serum testosterone levels in mice. Examples of chemicals that have been reported to cause neurotoxicity include benzotrifluoride, bifenthrin, and fipronil. An example of chemical reported to be immunotoxic is trifloxystrobin, a fungicide. Examples of chemicals toxic to the liver and kidney include benzotrifluoride and fipronil. The current PFASs designated group dates back to publications such as Bach et al. From 2011. As you know, since then, with the proliferation of research published on fluorinated chemicals, we have a greater appreciation of the broader scope of organofluorine chemicals present in the environment and in biota, including humans. At the March 2022 SGP meeting, the panel expressed interest in broadening the PFASs chemical group on the designated and priority lists, as did other meeting attendees. The current designated chemical group, PFASs, does not cover some important chemicals of concerns. Thus, we recommend replacing the current designated chemical group with the expanded chemical group, PFASs, and other substances with carbon-fluorine bonds. Justification to expand the chemical group includes the observation that the carbon-fluorine bond is extremely strong. As such, substances with carbon-fluorine bonds are persistent, and once released into the environment, there is an ongoing long-term potential for exposure. As briefly presented here and discussed in more detail in the document prepared for the potential expansion of the chemical group, several chemicals in the expanded group have been tested for toxicity and cause adverse health effects such as cancer, liver and kidney effects, and neurotoxicity. Expanding the chemical group is a resource-efficient approach. It will facilitate use of non-targeted laboratory screening methods for chemicals with carbon-fluorine bonds and identification of emerging chemicals of concern. Expanding this group will give the program the flexibility to choose to biomonitor for additional substances with carbon-fluorine bonds of potential health concern and be responsive to market shifts in use. Importantly, just because we can measure any chemical in designated chemical group does not mean we must or we will monitor for it. For example, as discussed in several previous SGP meetings, we can purposely decide not to monitor for pharmaceuticals. This slide concludes our presentation. Thank you for your attention.
Thank you very much. We have 10 minutes, so just to say how this next chunk of time is going to go before the end of the meeting, we have a moment here for clarifying questions from the panel, and then we have time both for public comment and then panel deliberation and recommendations to the program. So let's start with clarifying questions about this presentation. Yes, Tom.
One moment, we may have just gotten this. You need IT attention. I think I got hotspot with my phone. Can you do it? I think it's the internet. Do you want me to hotspot my phone? No. Yeah, that's it. Break. Send a message or put something on the screen. Just for the people who are. They see us. Well, it seems like everyone online can see and hear us, so I think it might just be a problem with this screen. I think we can continue while we try to.
Okay, thank you. So clarifying questions. Yes,
Yes.
sorry.
So that was a very useful and informative presentation. Thank you. And the question I have just goes to, and again, we agreed many years ago, right, that exposure potential is a very important factor. And given that the fluorine bond, the carbon fluorine bond is very strong, these are probably almost all likely to be very persistent chemicals. Right? They don't degrade well in the environment. So persistence is actually the best indicator of the potential for human exposure. There's one chemical property you could pick. I actually wrote a paper about this, but it is been demonstrated. So the only other factor would be quantity. And I would think that probably just knowing these are persistent, the next criteria would, well, toxicity, but in terms of exposure, the level of production. And that may be changing and going up or down, but that would probably be, because it's almost certain that if they are produced, they will be in the environment, and they will be in the environment for quite a while. The question is at what level. Anyway, just a kind of a thought, or maybe you want to comment on whether that's appropriate.
Thank you for your comments, and yes, it's hard to find production level information for all the, these chemicals. It's also hard to find use information for all these chemicals, but that's something we can continue to look for. But I think being able to biomonitor for them will also be important.
Any other clarifying questions for the presenters?
Carl has his hand up. Go
Carl,
ahead.
Pardon?
now we can hear you. Oh, Carl, we were, sorry, your hand was up for a clarifying question. Is that right?
I do. I agree with what Tom said. And I wonder if there's any indication that these myriad substances have undergone any kind of testing or careful screening before entering commerce. My guess is that they probably haven't, because of the structure of their law. So we're playing catch up, and this provision under the biomonitoring program provides a slight way to do something about that. Not a lot, but something. Any ideas about careful screening or legal testing?
Tom has a response.
Well, no, Carl, that's a really good point, that the US doesn't have a requirement, but the Europeans do. And one place to probably look for, probably not production information, but more details about toxicity, because in Europe, you can't, you have to go through the screen through REACH, and if you don't, you can't produce or use the chemical.
Right, but how much that influences what's around us, I don't know.
And just to modify that a moment, the data requirements are all tiered by tonnage band. So if you're not producing a lot of it in Europe, you don't have to provide health effects data, right? Like the health effects data doesn't come in until the higher tonnage bands. So that may not actually help us for the emerging chemistries as much as we wish it did.
Right.
Yeah, thank you. It was good, but we have discussed these expansions of the program many times in the past, and often there was a lot of literature that supported this. So here, although there are apparently 2,000 publications a year or something on PFAS in general, I found the information on production, current exposures, current knowledge of toxicity, a little lacking. I do understand what Tom said in terms of, in principle, if something is persistent, in principle it can be found, and in principle we can be exposed. But I thought that the evidence provided is not very strong compared to other chemicals we have seen in the past. So the other thing is, we mentioned earlier this morning that there are already in the ChemTox dashboard of the US EPA 12,000 compounds listed with fluoroalkene bonds. I wonder at which point it becomes too difficult in terms of, or too expansive in terms of really deciding which compounds to analyze. So for fipronil, I would say, yeah, definitely. There are 51 literature reports on fipronil in plasma, in human plasma. There's no question about it, but it's a pesticide. So, we don't want pesticides in blood, understood, right? But, just because something has a carbon-fluorine bond and the chemical properties were so different, from something that is an industrial intermediate, where it's unclear if people might get exposed and at which level and when, to something that are pesticides or closer to consumer products. I wish we would have more information on circling it better and also giving better advice what to look for in terms of properties of these chemicals and which kinds of chemical groups really to look for and include.
I feel like we're veering into discussion territory. Does anyone else have clarifying questions? In that case, I want to, we're meant to, sorry, Martha, did you have a? Oh, please, of course, yes.
Just to give some perspective, we realize that the group we have right now, it doesn't cover all the chemicals we know we have concerns about, doesn't cover the aromatics. And we want a group that addresses program needs and priorities, and those may change as we learn more about and as different chemicals are used in different ways. Our approach has been to be inclusive, to allow the broadest flexibility in what we measure, because we are an exposure-based program, and this list of designated chemicals is really a laboratory list of chemicals that can be measured. It allows us to use non-targeted analyses to get a sense of the presence and levels of these fluorinated chemicals and to identify chemicals within the group to focus on. I can also comment that we, also tried to come up with some functional or use-based definitions, but we don't really know all the possible uses that are happening right now or what might happen in the future of these fluorinated compounds. So that's a challenge for us. So.
Thank you. I meant to poll the room and attendees about how much public comment we anticipate, just in thinking about how to divide up the time. Stephanie, do you have a read on that?
We've only received one public comment so far, but if others want to comment online, can you raise your hand virtually?
Folks who want to comment online should raise hand virtually because our next section is public comment period, and we can then tell how much time to allocate to each comment. We'll give a moment for that.
I think we only have one comment that I can read.
Okay, then we'll move into the public comment period. We'll do this and we'll do our panel discussion. And if more public comments come in, sounds like we'll have time for them.
Definitely. And there's actually two from Anna Reed from the NRDC. She mentions that the EU's universal PFAS restriction proposal does have a lot of use information, more than we can collect here in the US. And then she submitted a longer comment that I'm going to read aloud. Good morning. My name is Anna Reed, and I'm a senior scientist with the Natural Resources Defense Council. On behalf of the NRDC and its members, I am pleased to support the California Biomonitoring Program's recommendation to expand the PFAS chemical group on the designated chemicals list to perfluoroalkyl and polyfluoroalkyl substances and other substances with carbon-fluorine bonds. The program's justification for expansion is scientifically supported, resource efficient, and will further California's ability to protect public health. The proposed expansion meets several of the criteria for designated chemicals under SB 1379, including chemicals with a potential for exposure and known or suspected health effects. Importantly, the concern over chemicals with carbon-fluorine bonds and the persistence that results is supported by other experts in the field. We thank California Biomonitoring and the Scientific Guidance Panel for their important work to protect the health of Californians. And that's it.
Okay, if that's it, and there's no public comment in the room, right?
Correct.
Okay, so if that's it for public comment, I think because we had more time allotted for it than that, I'll kind of return and check back and make sure that we don't have more public comment later, but we can move on to panel discussion. We're meant to end this period with a recommendation for the program in response to this proposal. So just so you know, have in mind where we're headed with this. Comments, discussion points, Lara.
Yeah, this is more of a clarifying question. It's Lara Cushing. I was wondering if you could say more about how this expanded definition would enable non-targeted analysis and maybe how a different definition would not? And because that seems like a real benefit to me too, in order, like, looking forward, being able to embrace new methods for non-targeted screening that are resource efficient and enable us to identify new emerging compounds. And is it like, could we not do that with a definition that was more restrictive, or like, has that been a barrier with some of the other chemical classes as they're currently defined?
Thank you. So I was looking to see if Junsu wants to chime in, but they can, you've heard from ECL talk about their non-targeted analyses of other types, not our biomonitoring California samples. And we've heard from other guest speakers over the years where they're picking up total fluorine in serum and then trying to see how much they can account for with what we know, what we're targeting for biomonitoring. There's a lot of unknowns, and some of that may not be captured by the individual chemicals that are currently on our designated chemicals list. So we would not be allowed to monitor for them in biomonitoring California samples. So it allows us to look for more once we find chemicals that we want to go after. We're measuring in people. Thank you. Ulrika.
Yeah, kind of following up on that, I mean, I think that is really one of the benefits of having this designated chemicals list, is it provides flexibility to be able to respond, as things change. And we know that things are constantly changing in terms of what's getting put into the marketplace, and, things that are chemicals that are discovered to have toxicities, they get rid of them, and then other chemicals that we don't know the toxicity of as well, or hasn't been as well defined, gets added. And so I think having that ability to both use non-targeted approaches and also maybe to develop targeted methods for chemicals that are within this broad group, that, as the presentation noted, there's evidence for human exposure for some of these, but they currently are not included under the definition of PFAS that's currently being used. So, I mean, I think from my perspective, it makes sense to have this broad designated category, realizing that, is probably never going to happen that we're going to measure every chemical that's, that could fall under that umbrella. But it does provide the flexibility to be able to, as things come up, as they be, maybe there's more evidence about exposure, and, we want to try to understand exposure better for a particular chemical that can just, the method can be developed without having to come back and, add it chemical by chemical to that designated list.
Yeah, Tom.
Just to follow up, and I'm going back several years when we took these cyclic siloxanes as a class for the same reason. And again, we were talking about a very large number of chemicals, but it was, the problem is we were just seeing them emerge in the market, and there's different variations. And our fear was that if we had specified a couple, it would we would limit the opportunity to then measure one that was emerging. So I don't know how to put the language. I favor the idea of giving some flexibility, but then, to avoid opening the door to like 10,000 every fluorine bond chemical, say it's open, but there needs to be some demonstration. I mean, the state has latitude, or the program, the biomonitoring program, I would say maybe recommend giving broad latitude to go into this class, but to also have some justification for which compounds and why. And again, along the lines of what they're doing, which is use, toxicity, and again, suggesting they look at whatever we can get from Europe about the types of uses and toxicity and exposure. So not limit, but also encourage them to be a little bit selective and careful. So we open the class up, but don't open it up to 10,000, so that everyone's overwhelmed trying to find the right code.
I wonder if part of what you're getting at there, Tom, is that is in a sense the difference between designated and priority chemicals. So, right, if we're expanding, the program is proposing expanding a list of designated chemicals in this way, and that's not the same as our instructing the program to prioritize that big a chemical list or a group. And anyway, I wonder if that helps partly get at that difference. I have Jenny, and then I have Oliver, and then Jose.
I agree we don't want to overwhelm anybody, but I think this problem is so perfectly suited to biomonitoring because, as you said earlier, look at total fluorine, what the heck is it? You know, so you have almost a top-down way of looking at it as well as the bottom-up, which is use and production and that kind of stuff. So I do think that the approach of finding the most abundant is in a way already weeding out problems using non-target, you know, if you apply non-targeted to see what's there or guess what's there and then investigate. So I think it is important, especially when you have this rapidly changing situation with potentially regrettable substitutions going on, you know, that it's really interesting to see the power of biomonitoring. And I think part of the problem is the source problem, that we really don't know what the sources are. And without that, it's hard to get at what Oliver said about finding the canary in the coal mine. So if we looked at all these different chemicals and we see which ones correlate with each other, these 2 tend to track together and these 8 track together, you know, then you might be able to whittle down the list to the ones that are indicative. But without knowing the sources and how they change, it's also concerning that your data from 2016 or something had things that correlated, but now they wouldn't because they've been changing. So I think it's a complicated problem, and I think it really does lend itself to biomonitoring as helping solve this problem.
Okay, thank you. This is all good comments. I understand the difference. We all understand the difference between designated and priority. But the point really is that eventually we want to do biomonitoring. And I would say 80%, maybe 90% of all the reports we have received were targeted reports on different studies, on different chemical classes and different compounds. So the non-targeted approach, although it's favored and, you know, always a hope, you know, like a carrot in front of you that you can't reach, hasn't been really shown to pay off, or at least not to the extent that we are all happy with it. Let's put it this way, maybe. So then you could say, well, you know, obviously targeted approaches can do quantification. You would have internal standards, you would have isotope dilution mass spectrometry for quantification, and then you can monitor across populations and, you know, so on in different biofluids and water and fish and you name it. For non-targeted, all you can really say is presence or absence, which is something. So I think it would be time for the program to not only expand designated chemical lists, but also try to see, can we say something about presence and absence? And if so, how? Now, we did discuss it before. For halogenated compounds in general, it's easier than for others. Brominated and chlorinated have really nice isotope patterns. Poly or perfluorinated also have nice patterns by being less than nominal mass. So if you have something like 20 fluorines, you can easily detect it in a non-targeted approach. And there are people who have published such things. Now, that is fine, but of course in a program, if you now want to look at exposure routes or different foods and different sources and soil and whatnot, that is overwhelming biomonitoring in California in terms of expense and, you know, informatics and so on. There is a resource called MassST in San Diego who collect public available MSMS non-targeted data for many years. They have 1 billion spectra so far. They have published many studies on different types of associations. They focused, of course, on microbiomes, but they also looked at bioacids and novel bioacids. But this resource can also be exploited for understanding non-targeted analyses. So if we expand our designated list of chemicals evermore, which likely we will do, just to give, nobody wants to restrain the program, but the program also has to show how it can be used. And instead of saying, well, we go for 300 people and do it, we can also do that. 300 people and some care or whatever ACE or whatever other program. And then we want to really look at non-targeted, we could do that. But also we could say, why don't we ask the program to see, can you find these perfluorinated and other types of halogenated compounds in MassST and similar databases that are publicly available and that have source information? So not to the level that you can use it in, body mass index and age groups and so on and so forth, not like in a real biomonitoring study, but at least for presence and absence and associations with sources. So that would be a comment and a pledge that I would like to do today.
I think that's very interesting. And following up on that, kind of sidetracking about my question in that sense and kind of bringing it back at the same time is, well, firstly, it is very, it's great that you've been giving some additional thought about expanding to different compounds that seem to have very strong carbon fluoride bonds there, and looking at dietary sources of exposure. In this case, looking from the agricultural side, including pesticides. I see some pyrethroids in there, and fipronil that was talked about. The same questions kind of come back when we're thinking that there are thousands of different chemicals, and coming from a list of thousands to 10 different chemicals, from selecting from that, I am sure that we could make the rationale that we could include maybe a dozen more that might fit the same criteria that are mentioned here. So my comment here would be, it would be very interesting to start incorporating different criteria and actually having a strong list of criteria now specifically to be able to score somehow which chemicals should be then included in a designated list such as this one, given that there are a lot of different resources, some of which Oliver was talking about, thinking different ways in which some sort of a score could be created such that we can start prioritizing or including specific lists of chemicals, given that, as I was mentioning, if there are 10,000, 15,000 chemicals worth considering, probably a good amount of those would qualify here in the exposure potential list and probably in the health effect list, right? So maybe you've done this. I didn't fully see if there was some sort of a scoring criteria for that to be able to include these in there, but it would be nice to get some thought of how you've been selecting these in that sense.
This is Martha Sandy. So it's been a while since we brought chemicals to our panel to put on the designated list or the priority list. And again, just to remind you, the criteria for the designated chemicals to use, that's in the enabling legislation. And you as the panel will use those criteria, and the criteria are not joined by the word and, so a chemical or a group, but to put on the designated list just needs to meet at least one, but it's the recommendation of the panel as to what should be on that designated list. And again, it's a list that allows us to biomonitor if we find information. And as you hear, we aren't monitoring all the chemicals on the designated list right now, but it gives us the flexibility if we understand more about a particular chemical within one of the designated chemical groups that we really want to look at.
We're moving toward a recommendation. So what we're asked to do is the current designated group is perfluoroalkyl and perfluoroalkyl substance. Perfluoroalkyl. It says both, right? Okay. Polyfluoro. There we are. So it's very restrictive. It's perfluoro and polyfluoro. And then it's expanded to other substance with a carbon fluorine bond, which is like going from this to the whole room. But maybe, I mean, if we just put a little bit of a restriction on the addition, other substances with carbon fluorine bonds that meet the criteria of the enabling legislation. Which is, we're expanding the group to something new, but we're also saying it's not a free ticket to look for every, but that's already there. As Martha pointed out, there's already a restriction because you can't go outside of the criteria and the enabling legislation. So, I mean, we might want to emphasize that so that we don't feel like we've opened the door to, 10,000 new chemicals.
I feel like the most important thing that I keep coming back to in this is sort of language from the presenters about being allowed to look. And I feel like we have many different roles on the panel, and sometimes we make recommendations to the program about what we think they should focus on and how studies should be conducted and priorities for, expending the limited resources on doing studies. And for me, when the question comes to what should we permit the program to do, what should they be allowed to do, that gets a lot less, I want to be a lot less prescriptive in that. That's a place where I don't want to limit the program, especially because we've all, I think, acknowledged how dynamic the marketplace is around PFAS. I mean, around many chemicals, but particularly around PFAS, with increasing categories coming under scrutiny, gaining attention, and then how that shifts. And my impulse here is to allow a very broad definition, even acknowledging that there are many things that the program would never consider monitoring that qualify as a single carbon fluorine bond, but sort of acknowledging what a long deliberative process this has been, and should a chemical emerge that there's rationale for studying, not wanting to have to limit them to like redesign the group just in order to be able to include that. Like, I feel like the deliberative process in selecting chemicals to study and in designing studies is already very robust, and we get to have input on that. And so the idea of limiting the program through the designated group doesn't feel necessary to me. It's kind of how I'm seeing it. I don't know if others have comments on that. Jenny.
Just want to say that I agree with you on that point. And are we moving to making a motion at some point, or what is the next process?
We should have a motion before this time is up because we need to make a recommendation, but we can fully let the discussion run its course before doing that. We don't have any time pressure. And it looks like Stephanie has a comment, or public comment. Okay.
This is again from Anna Reed from the NRDC. She states that the California Water Board is planning to perform non-targeted testing on drinking water in collaboration with EPA. This expansion would allow California Biomonitoring to follow up with interesting and important findings from this work.
Other comments from the panel or discussion points? Tom.
Well, that's an interesting example of what we want to give the program an opportunity to do, which is to respond to new information that comes out. I mean, that's the example from NRDC. Is like, oh, look, there's this whole new data set. And then if we restricted in some way the class of compounds, fluorinated compounds, then they'd have to say, well, we have to get permission, as you said. So I favor your comment as a recommendation, which is that we do allow the broad expansion with our understanding that that's not a requirement or even a suggestion, that they just do non-targeted screens for every fluorine carbon bond, but that it gives them some openings to go And again, I think we have to assume the program criteria, the enabling legislation is sufficiently protective that it doesn't mean this is giving free rein to just go out and look for every compound in this class.
I would say the enabling legislation and the budget. If anyone has concerns about overreach, you could put those aside, I think. Other points in the discussion? Other thoughts about this designated chemical group? Would anyone like to make a motion for a decision if folks feel like they've deliberated all they need?
No, I make a motion that we allow this class to be expanded as the proposed definition. And I don't know, I wouldn't put a qualifier on it, but I think we understand there are budget constraints and, requirements that contain the set of compounds still. It's not, we're not opening it up to an entire universe. But I don't think we have to put that qualifier in our recommendation. I think the recommendation would be to allow the language to be revised as proposed in the title of the presentation.
So maybe just to restate that for the record, I would say that Tom McCone motions that the chemical group PFAS and other substances with carbon fluorine bonds be included as designated chemicals for the California Environmental Contaminant Biomonitoring Program. Do we have a second?
I second.
Seconds? Oh, okay, we have a second. So then I will, I'll just go around and record votes of every panel member. Laura agrees. Tom?
Aye.
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 And Carl? Oh, we can count that as an agree. Okay. And I also support the motion.
Aye. I was muted.
There we go. Okay, so with that, the motion passes unanimously. Great. Okay, so we're a little ahead of schedule, which is wonderful. People will get a little bit more time for lunch. We had a pretty tight lunch turnaround before. So I want to just open up the public comment period now, and this is not specific to items on the agenda for today. There's 10 minutes allotted for open public comment, and commenters can provide any comments on any topic. Webinar attendees can submit written comments and questions via the Q&A function of Zoom webinar or by email to biomonitoring@oeha.ca.gov, and we'll read them out loud. If you wish to speak rather than submit a written comment, please alert us using the raise hand feature in Zoom webinar, and we'll call on you. And if you're attending in person and wish to comment, please come to the front of the room or raise your hand. And reminders to public commenters that for the benefit of the transcriber, please clearly identify yourself before providing comment and write your name and affiliation on the sign-in sheet. So with that, as having provided a little time for those comments to come in, Stephanie, is there any to report?
No public comments have come in, no.
Okay. In that, oh, sorry, go ahead.
So there was a comment that we were given in advance. Do we have to, should we acknowledge that or we haven't?
Program
That
staff
was
is
specific for this meeting.
so that concludes the substantive portion of this meeting rescheduled from August. The transcript of the meeting will be posted on the Biomonitoring California website when it's available. The next SGP meeting will be this afternoon from 1 to 4 p.m. And information regarding options for attending the meeting are available on the meeting webpage for this afternoon's meeting. And I want to note specifically that there's a separate Zoom link for this afternoon's meeting. It's a different meeting for those joining online, and that's available on the webpage. So with that, I want to thank program staff, today's presenters, the panel and the audience, and I'll adjourn the meeting. Thank you.